This time, we'll explain the measurement process to acquire the oscillation margin. Oscillation margin provides the limit at which oscillation stops. This is one of the most important parameters for the oscillation circuit. And it is an index of the signal amplifier of the circuit without a crystal unit. The oscillation circuit can theoretically operate when the oscillation margin is 1 or more. However, if the oscillation margin is close to 1, there is a chance of no oscillation. Please also understand that the circuit will not operate if the oscillation startup time is too long. These oscillation issues can be modified by inducing a larger oscillation margin. Oscillation margin is calculated by the following formula using the negative resistance and crystal ESR spec. The absolute value of negative R is the negative resistance indicating the amplification capacity of the oscillation circuit. ESR spec means equivalent series resistance specification. The oscillation margin is the ratio between these two. The ESR spec can be found in the catalog or datasheet of the crystal unit. Please note that the negative resistance is measured on the actual oscillation circuit. This is key when measuring the value. The measurement process of negative resistance. We add a resistor in series with the crystal unit and check if the oscillation circuit is operating, and continue increasing the resistance to confirm the maximum value. The maximum RS value is RS max. Also, there is RE, the effective resistance of the crystal unit. The negative resistance is calculated by the sum of RS max and RE. Effective resistance, RE, is the resistance at the actual oscillation frequency. It is calculated from the crystal unit's equivalent circuit constants and the load capacitance spec, CS. RS max is measured on the actual PCB and resistor. Please watch the following video depicting the RS max evaluation process at our test lab. Finally, I'd like to introduce an oscillation margin example calculation. RS max, measured by the process in the video, is 1000 ohm. RE, the effective resistance of the crystal unit at the actual oscillation frequency, is 50 ohm, for a total negative resistance value of 1050 ohm. If the ESR spec of the crystal unit is 100 ohm, divide 1050 by 100 for an oscillation margin of 10.5 times. It is very important to create a stable oscillation to confirm the oscillation margin. We hope today's measurement and evaluation process explanation was helpful and can be used in your actual circuit design. If you have any questions or concerns about measuring the oscillation margin, please contact Murata. Thank you for watching.